Hi everyone. In the series of theory of computation lectures, today we'll see powers of sigma. Right. In the previous lectures, we were discussed about what is symbol, what is alphabet, what is string, and what is language. I hope everyone remember what is symbol, and from that we derive what is alphabet, and then from that you can derive strings. And in last lecture, we discussed what is language, right? So these things we have already discussed, and today we'll see what is powers of sigma, right? So you know what is sigma. Sigma is the input alphabet set. Here we just consider A comma B as the members of the sigma, that is input alphabet set, and today we'll see what is the powers of sigma. Okay. So first we'll see sigma to the power 0, which means we'll see what will be the member of the sigma power 0. Okay, so this denotes that set of strings of length 0. Okay, of length 0. Okay, which means what is the meaning of this set of strings of length 0 denotes sigma power 0. So which means that we will not have any element on the set sigma power 0. So they count that the length of the sigma is equal to 0. Okay, this statement is true, right? Because set of strings of length 0, there will not be any element with the length 0, right? So which means the length of the sigma set sigma per 0 will be 0, right? And you can also you can mention this as sigma per 0 is equal to, you can say, it contains empty element, right? You can take note. In the first lecture itself, I have given the symbols, what is meant by epsilon, right? Epsilon is the empty set. It denotes the empty element, right? So this is how we can denote the sigma per 0. Sigma per 0 means set of strings of length 0. That is what sigma per 0. And next, sigma per 1. What is mean by sigma per 1? So you can define like set of strings of length 1. Okay, so let's say of length 1, which means that the set contains, we have two symbols, right? So the length should be 1, which means we will be having only a comma b. Other than that, we will not have anything. Only set sigma per 1. Okay, this is the set sigma per 1. And now we'll see what is sigma per 0. Sigma per 2. Set of strings of length 2 is called sigma per 2. So otherwise you can mention sigma per 2 as sigma dot sigma. That is sigma multiplied with another sigma, right? So now what is sigma? So this is sigma and sigma per 1, everything is same, right? So what is sigma per 1? This is called sigma per 1, right? This is how you will get sigma per 2, right? So now sigma per 1 means a comma b and a comma b, right? You have to multiply these things, so you will get a, this things ab, and then you will get ba, and then you will get bb, right? So these are the members of the set sigma per square, right? This is for sigma per square. Okay, and then we see what is sigma per 3. Set of strings of length 3. Okay, length 3 means what? You can you can make it as sigma per 3 is equal to sigma into sigma into sigma. You can make like that, sigma into sigma into sigma. Otherwise you can also have sigma square dot sigma, right? So sigma square, we have 4 elements, and sigma we have 2 elements, and you have to multiply these things. You will get 2 times, you will get totally, you will get 8 elements. So it will be length of the sigma cube will be 8, right? So length of sigma square is 4, right? Length of sigma square is 4, right? Likewise, you can have sigma per n. So we have to find out what is sigma per n. So sigma per n is defined as set of strings of length n, right? This is what sigma per n. So likewise you can also denote sigma per star. Okay, so sigma per star means, what is sigma per star? So this means that sigma per 0 union sigma per 1 union sigma per 2 up to sigma per n, right? This is how you can denote sigma per star. So actually the sigma per star is the universal set. Okay, universal set. We can call the sigma per star as the universal set. Universal set. So universal set in the sense whatever strings we are forming, that will be comes under sigma per star. So now in the previous lecture we were discussed languages, right? L1, L2 and L3. So L1 we were describing L1 as the set of strings of length 2. That is what L1, right? In the previous lecture we were formed the elements of language L1, right? L1, L2, L3. So all the L1, L2, L3, all will be, these languages will be the subset of sigma per star. Okay, because sigma star will have the elements as, what is sigma per star, what is the element here? Epsilon, right? Epsilon will be a member, and then union, what is the sigma per 1? We'll have a comma b union a, that is sigma per square, sigma square a b b a b b union up to sigma per n, right? So which means that, so whatever strings you are forming, that will be fall under sigma per star. Okay, sigma per star. So here sigma per star is including epsilon, right? Empty set, right? So now we'll have two nodes. The first point, number one, node number one, node number one. Okay. So what number one is that? Just note down that number of strings over the alphabet set sigma will be finite set. Okay. So whenever you are forming some strings over the alphabet sigma, that string will be finite. Okay, okay, but whenever we are forming languages over the set sigma, that will be infinite, right? These are only two nodes, we have to take it from these concept. So the first one says that number of strings formed over the input set sigma will be finite set. That will be finite set. Okay, sigma star will be finite set. So what number of language formed, number of language formed over the set sigma star will be infinite, right? These are only two nodes you have to note down. Okay, this is what the powers of sigma. So we will also revise the concept. So we are just assuming that sigma contains two elements a comma b, and what is sigma per 0? 0 means with the length 0. You have to form the strings of length 0. Okay, which means that we will not have any strings with the length of the sigma 0. Sigma per 0 will be 0, right? There will not be any element. That will be denoted as epsilon, right? That will be denoted as epsilon. Sigma per 1 will be set of strings of length 1. That is, the length 1 means we will have a, either a or b, and sigma per 2 means we can make it a sigma into sigma, so which means we are getting 4 elements. Okay, combination. And sigma per 3 means it will have 8 elements. Sigma per n means we will have how many elements? Length n means, in the previous lecture itself we have discussed, right? How many number of strings forms over the alphabet sigma. The symbols of the count of the number of elements present in the set sigma is 2, right? So the length is 2 per n, right? The count is 2 per n. Okay, these many strings will be present in the set sigma per n, right? In the previous class itself we have discussed this. And sigma per star consists of sigma per 0 union sigma per 1 union sigma per 2 up to sigma per n. So likewise it goes on. So sigma star is the universal set here. So universal set here, these are all the members of the sigma pi star. So from here we are getting two notes. The first note is that number of strings formed over the set sigma pi star will be finite set. Number of language formed over the sigma star will be infinite, right? These are only two notes we have to take it down. This is what powers of sigma. So I hope you understood what is powers of sigma. We'll discuss the next concept in the next lecture. Okay. Thank you.